inform those who are not joining the class to join the class now, yeah, because it's already 10:03 already. It's supposed to start the class already. Or there's still more than half of you are not enough. Okay, good morning, class. Can you hear me? Can you hear me or not?
Yes.
Okay, let's start the class. There's still half.
Okay.
Don't care already. Okay. Right. Let me project. Let me do the recording first. Yeah. Okay. Let me project my screen. Okay. Can you see my screen?
Yes.
Okay, last week we are talking about the solar energy and so forth, right? So today we are looking at the advantage of solar energy. What are the advantages that solar energy has? Okay, so solar energy has the following advantage over conventional energy. Conventional energy means the fossil fuel and so forth. So the energy from the sun is virtually free after initial cost has been recovered. It is free, but it's not at the initial stage, because initial stage you need to set up the solar panel. That one is quite costly. Okay, so it's after the initial cost, after you set up the solar panel, everything. Then after that, subsequently, the generations of energy from sun is virtually free because you no need to pay anything to sun, right? So it's depending on the utilizations of energy. Payback can be very short when compared to the cost of common energy sources. Yeah, so the payback that you regain back the money of your this solar panel, it could be very short. Well, very short time you can get back your money. Yeah, as compared to the common energy sources such as petroleum and so forth. Solar and other renewable energy system can be standalone. You no need to transfer, you no need to require to connect it with the power grid or natural gas grid. Okay, if you look at our electricity, there is a grid there to transfer the what we say the energy to other places. But as far as the solar energy is concerned, it can be standalone. You no need to have grid, yeah. And the sun provide a virtually unlimited supply of energy. Every day we also have sunlight, isn't it? Especially in those countries that near the equator. Yeah, but those countries that have four season one, that is another story lah. Yeah, the sun provide a virtually unlimited supply of solar energy, especially in the country that near the equator. The use of solar energy displaces conventional energy, which usually result in the proportional decrease in greenhouse gas emissions. Yeah, and solar energy does not emit any greenhouse gases. Okay, but the conventional energy like fossil fuel, all this, when we burn it, the carbon kept inside the fossil fuel will be released as a carbon dioxide as a greenhouse gas. Whereas the solar energy, there is no emission of greenhouse gases. Yeah, and the use of solar energy is an untapped market. Why it is untapped market? There is still high potential. Yeah, the use of solar energy is still high potential, and because now less people using because the solar panel is rather expensive. Yeah, and efficiency of the solar panel, the energy that we can get from the solar panel is quite low. So that's why there is still a big potential. If we can improve our technology to increase the yield of the electricity from the solar panel, then and the lower down the cost of the solar panel, then it will be a huge market. Yeah, so it's an untapped market. Okay, so this one just tell you what you need to do is you get the free energy from the sun. What you need to do is just collect it. Okay, but before you collect it, you need to set up the solar panel. Okay, so now what is the main usage of solar energy currently? Currently, the solar energy usage, mainly is used for cooking. All right, use solar oven, stove, and so forth, and use for heating up the water, uh, drying or products. If let's say you're manufacturing certain products that you need to dry it, you may use sunlight to dry it. Okay, and desalination, salt production process, yeah, to produce salt. So this one is only example of low heat temperature energy usage. Yeah, all these are not require the high energy usage. So this graph, this photo just show you some example. This one is experimental. It's not the actual applications. Yeah. Okay. Now, when the sun's energy come to the earth, okay, there are two ways for us to collect the sun energy. One is natural collections, okay. Natural collection is the sun will heat up the ocean and then causing the ocean have a different temperature. Maybe the surface is higher temperature, the bottom of the ocean is lower temperature. Yeah, and then this one, the difference of the ocean temperature, we can use it to harness the electricity, the tidal wave energy. Yeah, and also the wind when the sun causing the different pressure, the different temperature in the atmosphere, it causing different energy, different pressure in the air. And then when there is a different pressure, the winds will happen. Winds will blow from the high pressure place to low pressure place, and we can use this wind to do the mechanical work or to this to generate electricity. Have you heard about wind power? That where we have a big turbine that we can generate electricity. Okay, so this is a natural collections. Yeah. Then another one is a technological collections. So in which we do not depend on the natural situation. We use a technology to harvest the solar energy. Yeah. So for example, we can use a thermal, or we use the photovoltaic cell, the solar cell to harness the electricity. And then if we use a PV cell, then we can generate electricity. Okay. If we use a thermal transmission one, this one you can just only produce heat. Yeah. So this showing you the area where we can harness the solar energy in the America. Yeah. Okay, modes of solar energy collections. How can we collect the solar energy? The common one is a photovoltaic or photogalvanic cell. Yeah. And then this is also called electrical solar cell. Then another one is photothermic cell, which is a selective coating which absorbs solar energy well but emits poorly at higher wavelength, landing to coating becoming warm when exposed to sunlight. Okay, so this is another cell, but then it is not as good as the photovoltaic cell. Then another one is photosynthesis. This is a natural process where the plants absorb the solar energy and resulting in the production of biomass. Yeah, the photosynthesis everybody knows, isn't it? Right, the plant absorb carbon dioxide and sunlight and then convert into the food or whatever, then production of biomass. And then ocean thermal gradients, the different between heated and top layer of ocean water and the cooler bottom layers. then there is a difference in temperature than causing a tide, a wave. And then this one we can use it, ocean thermal gradient. The difference of the ocean temperature, we can use it to collect the solar energy. Yeah, and wind energy also, we mentioned just now, heating of the air to give rise of different pressure, air pressure and air mass flow. Yeah, the when the atmosphere have a different pressure because of the different temperature, then the wind would be generated, and then we harness the wind energy. For your information now, with the current technology, if we want to harness the wind energy, the wind need to have a certain speed. There is previously is 3 meter per second. Now as low as 2 meter per second. The speed you can harness the wind energy already. Okay, so this diagram show you a piece of solar cell farm, and you can see that it need a very big area. Okay, to install all the solar cell. Yeah, this is another area. You see this part and this part. Okay, and actually we saying that uh, solar energy does not create pollution. In the sense, yes, when it generate the energy, it does not emit greenhouse gases. But when we install the solar cell, actually we are causing destructions to the land. Okay, for example, here you cannot have anything that tall enough to block the sunlight. So you need a big piece of land. Okay, this indirectly causing a land pollutions where you need to chop down the trees and so forth. Okay, and then this is something like the aeroplane light is powered by the solar energy. This is another one, solar furnace. Yeah, and this is commonly seen at our house in Malaysia. Is any one of you have a solar cell put on the rooftop to harvest the solar energy to heat up the water to heat up the water? Is there any one of you, your house have this solar panel? Any response from you? Yes?
No.
No. Are you staying in condo?
No.
No. Okay.
Landed.
But have you seen this before?
Yes.
Yes.
It's quite common. In some houses, they put the solar cell at the rooftop. This is why it's not for generating of electricity, but it's for heating up water and so forth. Okay. And then this is another large-scale solar enclave in Malaysia project. Okay, what are just now we are talking about advantages of the solar energy, right? So the main advantages is we can say that it is renewable, okay, and whether it is no polluting or not, non-polluting energy or not is a question mark. Depends on which angle are we looking at. As I mentioned that just now, when we have a wind energy, actually we need a big piece of land, okay, so it may cause a land pollution because we need to do deforestations or whatever. Yeah. And what is the disadvantages of solar energy? There's the disadvantages. The main one is low efficiency. Yeah, the lower power source, 1 kilowatt per square meter, low efficiency around 10 to 15%, and you need a very large collection area required. May have environmental impact on the collection area. Yeah, as I mentioned just now, you are causing the land pollutions. Yeah, and very high initial cost or capital cost. Now the price is dropped, but then it's still expensive. Yeah, and high cost of solar energy collection equipment such as solar cell. Even though the price has dropped, but it still is a very expensive one. And China is one of the world largest solar cell manufacturing country. Yeah, and it require a storage medium. So you harvest the solar energy in the daytime. Then after that, you need to store it. Okay, you need to store you need to store the energy. And also because why we need to store the energy due to variability in availability intensity. Because in the daytime, sometimes the weather is very cloudy, so the energy generated from the sunlight will be low. Okay, and when it is a very sunny day, the energy generated will be high. And so all this energy generated, you need to store it. So you need a storage medium. Yeah. And presently, the storage medium is not so effective yet. And it is a high cost to a consumer. Why? Because of the high initial capital cost. Yeah. If you want to have a harvest a solar energy as what I shown in the photograph just now, then you need a very high cost. So by consumer, if you want to put in into the solar panel at our rooftop, it is also quite costly. Yeah. And next graph, this one is showing that the total energy that harvest from the solar energy against the year. You can see that is increasing sharply, especially approaching year 2000. Yeah, is increasing sharply. More and more people is using the go for solar energy. And once the more and more people going for solar energy, definitely the cost will coming down. Yeah, the photovoltaic cost will coming down. Yeah, and you can see that it becomes cheaper and cheaper. And in China, they are planning to drop down the solar power price to 0.146 dollar per kilowatt. Okay, this is their aim lah. They want to make use a cheaper solar panel. Okay, after the solar cell, the next power energy source that we are looking at is hydroelectricity. I think you all have heard about hydroelectricity, right? Where we need to build a dam to generate the electricity. Okay, then the what are the advantages of the solar energy? The advantages is pollution free. Again, this pollution free is a question mark depending on which aspect are we looking at. Okay, after the commissions of the dam, after the installation of all the equipment, the generations of electricity we can say is free. But at the time of at the dam construction or whatever, again it may cause deforestation or relocate the village or people to another city or another place. Okay, because you need a big piece of land, and it is very high efficiency as compared to solar energy. It is very high efficiency, and then little waste heat, and then it is low cost, approximately 4.5 cents per kilowatt. Easily adjustable output, recreational advantages. Why does it mean by recreational advantages? When you have a dam, usually they will convert the dam into the park for jogging or whatever, isn't it? Right. So one side is the dam for generate the hydroelectricity, and then another side they use it for recreation purpose. And it is also used for the water storage and also flood mitigation. When there is a flood, the water will be allowed to accumulate in the go flow into the water storage dam there. Okay, so it's a flood mitigations. And disadvantages, what is the disadvantages? It will affect our riverine ecosystem. That's why I say just now, is it pollution free or not depends on which angle are we looking at. If we are looking at the land, it may have effect on our ecosystem because we are going to change the directions of the river and so forth. And then the sediment may build up and then dam failure, causing the dam failure of the sediment because the water is not a clean water. There have some sediment build up, change the watershed characteristic, alter hydrological cycle, extensive flooding area, usually far from users, danger of dam collapse and flooding. If the dam is collapsed, then the surrounding area will be flooded. Yeah, so these are the disadvantages. So the pollution free, this one, as you can see, and the disadvantages side here, actually it caused some destructions to our ecosystem. Yeah, especially the land. So whether it is really pollution free or not is depend on which angle are we discussing it. Next, once the dam is built, the energy is virtually free. Yeah, after the dam is built, all your cost is done already. Then the energy is virtually free because you are using water. However, cost of maintenance, distilling, turbineware still a problem, but you still need to have a cost for maintenance. Yeah, and there is no waste or pollution produced for the hydroelectricity. And then this one is subject to argument also. There are some scientists has found that actually there are some in greenhouse gases being emitted from the hydroelectricity generation plant. Okay, but the amount generated is very low, so that's why we claim it as no waste or pollution produced. Much more reliable than wind, solar, and wave power. Why it is more reliable? Because we can control it anytime. Whereas if you are using the wind power or solar energy, you have to depend on the mother's nature. When we have a cloudy day or when you have a sunny day or when you have a strong wind or whatever, is beyond our control. Whereas electricity, hydroelectricity is within our control. That's why it is more reliable. Yeah, and water can be stored above the dam, ready to cope with peak seasons. Yeah, you can store when the peak season that you need more you need more energy, then you can have more generation of electricity from the hydroelectricity plant. Hydroelectricity power station can increase the full power very quickly, unlike other power station. That's mean we can we can change the output of the hydroelectricity power, okay, in a very quick way, okay. And electricity can be generated constantly because we can control the turning of the turbine consistently by using water, okay. So next we look in more, just we have discussed about the disadvantages of hydroelectricity. Now we look in more details about the disadvantages that we have. Okay, the dam are very expensive to build, okay? And also maintenance can be a problem with silting danger of a dam collapse. So if the dam is collapsed, then the surrounding area will be flooded. However, many dams are also used for flood control and irrigation, so the building costs can be shared. So the multi-purpose dam, okay? The dam is built not only for generating of electricity, but it can also use for flood control and irrigation and so forth, okay? And building a large dam will flood a very large area upstream, causing problem of animals and the use of life there. This is what the ecosystem, the damage to the ecosystem that we mentioned about earlier. Finding a suitable site can be difficult because you need a big area of land, and then there is no the impact on the residents and the environmental may be unacceptable. Okay, in China there was one Three Gorges Dam. It's a very big dam. When we built the dam, they have relocated thousands of people. Okay, there are thousands of people are living in that area, but because they need that piece of land to build a dam, so they relocate the people to another place. Okay, so this is quite a big project, yeah. And water quality and quantity downstream can be affected, which can have an impact on the plant life, yeah, because we divert the directions of the river and so forth. Okay, so it become the affect the impact of life. There is some dam originally the place is very fertile, but after they build a dam and then the water flowing directions is changed or whatever, and then the land is no longer suitable for agriculture. Yeah, and another side effect is it will affect the hydrological and watershed characteristic of environment, as what we mentioned earlier. Okay, this is environmental challenge solutions. I do this one I leave it to you to read on your own. It's just for your informations. And the next one I show you where are the locations of the hydroelectricity power generation. You can see that most of the country we also have using hydroelectricity. Okay, but in Malaysia hydroelectricity is not that common. Yeah, in Malaysia, the electricity we are generating basically using natural gas and coal. Okay, and only a small percentage is using hydroelectricity. And you see, this one is a report by people claiming that Malaysia Dam project, we want to build a dam in the Sarawak. They are saying that our dam project will threaten the World Heritage Park. Okay, we conserve the national park or whatever. It will destroy it. Malaysia plans to build a series of hydroelectricity dam on Borneo Island, threaten the World Heritage status. Yeah, so that is causing a pollution, a land pollution. Yeah. Okay, so this is this cartoon. It just show you the hydroelectricity, the dam. Yeah. Okay, the next energy that we are looking at will be wind power. Okay, wind energy. It is a minimum economic speed of 5 meter per second, but now with the new technology, it can go to 2 meter per second. Okay, as far as your wind speed is 2 meter per second, then you can harness the wind energy. Advantages: it is renewable and non-polluting. Again, same as hydroelectricity power generation plant. Is it really non-polluting or not? When you want to build this wind tower, wind turbine, you need a big piece of land, and you cannot have a high-rise tower nearby because high-rise tower will block the wind blow, and then it will slow down the speed of the wind. Okay, so this also indirectly causing a land pollutions. But what as compared to the solar panel is the bottom side, the ground there, you can use it for planting some other plants. Yeah, ground can be used for other purposes because the wind turbine is very high. Yeah, and the ground that it would not affecting the speed of the wind, you can use it to plant some crops. Yeah, and this advantages is high variable. why is high variable? Because it's beyond our control. It depends the speed and direction of winds. All are it depends on by the natures, man, the mother's nature. What is the speed and what is the directions? The direction of the wind may change. Yeah, and anesthetic is it is visual. People call it visual pollution because in a piece of land you are building all the tall this wind turbine, so that it make the aesthetic of the of the or scenery of the place not so nice. Yeah, so it called anesthetic and may disrupt migratory birds pattern. Yeah, it will kill the birds that migrated to there and requires large expanses of open land. You need a big space of land, just like the solar panels, solar energy, and it is far from user. Okay, what are the benefits of wind energy? We look in just now we're talking about advantages, right? So now let's look in details. What are the benefit of wind energy? Wind energy is an ideal renewable energy. Why? Because it is pollution free, and again, this pollution free is question mark. Yeah, depends on where you where are you, what angle are you looking at it? Okay, if you are looking at the visual side, then you may say a visual pollution. Yeah, it's aesthetic. If you're looking at the land side, it may cause land pollution because it need to conduct a deforestation or just relocate the people, just as what happened for the hydroelectricity power. Okay, infinitely sustainable from form of energy. It is no renewable energy. Yeah, it does not require fuel. It does not create greenhouse gases. It does not produce toxic or radioactive waste. So these are the advantages or benefit of wind energy. And wind energy is quiet. It does not present any significant hazard to bird and other wildlife. Yeah. This one is also subject to argument. There are some people, some scientists claim that the wind turbine tends to kill the bird or whatever. Okay. And just now when we talk about these advantages, you say that disrupt the migratory birds pattern, isn't it? Right. So this one is a question mark. When large array of wind turbine are installed on farmland, only 2% of the land required for the wind turbine. The rest is available for farming. Okay, so the 98% of it of the land that you can use it for farming, livestock, and so forth. And then if you are own the land, then you can get the rental from the user of the land. Okay, the landowner often receive payment for the use of their land. Okay, this is provided you own the land. The ownership of wind turbine generated by individuals and the community allow people to participate directly in the preservations of our environment. This is, I think you know, megawatt hour of electricity that is generated by wind energy helps to reduce in approximately zero point 0.8 to zero point 0.9 tons of greenhouse gases emission that are produced by fossil fuel. Okay, so if we are replacing the fossil fuel consists of three things: coal, oil, and natural gas. Okay, so if you are using this one, if you're converting from the fossil fuel to the wind energy, you can reduce around zero point 0.8 to zero point 0.9 tons of greenhouse gases emissions. Yeah, that is quite significant. Okay, so this is just show the problem during winter. There is no wind, so the snow is on top of the turbine. So we have to wait until when there is a wind, then only we can generate the energy. Okay, next let's look at the distribution of wind energy capacity. Yeah, in year 2000. So in now 2020, I do not have the latest statistic. Okay, the country that generating the highest wind energy is Germany. Yeah, 6,000 megawatt. Then followed by United States, and India also have 1,000 megawatt of energy generated by wind. Okay, and next I show you a photograph of the wind turbine. You can see that this is a very tall tower, and then the wind turbine is here. All right, that's why people say that it spoil the scenery of the land. That's why it's causing the visual pollution. And down here, you actually is you can use it for other purposes like planting a crop, planting a vegetable or whatever if the weather is suitable. Okay, this is another picture of a wind energy. Okay, same as the solar energy, the amount of the energy that we harvest from the wind is increasing, yeah, because we are gearing towards the use of renewable energy. So that's why you see near the year 2000, the energy, the megawatt of wind energy is increasing, yeah, and same thing as more and more people using the wind energy, the cost of the building the turbine and whatever is reduces, yeah. Okay, this is supply and demand. This is cost per kilowatt of wind energy. You can see that it becomes cheaper and cheaper. And this graph will just show you some statistic. What is the capacity of the world and the selected country? Okay, the generating capacity. For example, in 1980s, the US is only generating 8 megawatts per year. Then now it becomes 4,000 plus megawatt. Okay, and then the world, you can see that the worldwide megawatt generators increased from 10 megawatt into 23,300 megawatt. Yeah. Okay. So this is just a statistic for your information. This one is electrical and hydrogen energy. We will show you later. Okay. The next energy that we are going to talk about is geothermal energy. Geothermal energy actually is energy under the ground. Okay. And advantages it is high efficiency. Yeah, low initial cost, the installation of the equipment or whatever for you to harness the geothermal, it is low. Disadvantages that is it is non-renewable and then slow cycling time. It takes times to generate the energy, and usually it is far from user. Okay, so this is the geothermal energy, and then beside the geothermal that we get it from underground, one of the disadvantages is people claim that it is very noisy. Okay, when it is operating, it is very noisy. And then another one is tidal wave, tidal energy. Advantages that it is free and steady source because there is always a wave in the sea, isn't it? Right? And disadvantages that is low duty cycle, high modification of coastal environment, and very high cost. Okay, if you want to harness the what we say the tidal energy, you need to modify your coastline area. The coastal environment is being disturbed. Yeah, and the installation of the plant is very costly. Okay. So I just for your info. Geothermal electricity generations technology consists of either flash technology or binary technology. With flash technology, water from 300 to 700 degrees Fahrenheit, not Celsius or Fahrenheit, but it's still in liquid form, is piped from its highly pressure underground reservoir into the geothermal facility. You see that we are harness the energy from underground. Yeah. Once the superheated water is released, it flashes into steam and then drive the convention turbine engine. Under the high pressure, the steam, even though is very high temperature, it due to the high pressure of the ground, it is still in the water form. Okay, once it emerge out from the earth surface, then it turn into steam, and we use this steam to generate the electricity. Yeah, with binary technology, underground reservoir water of lower temperature are used for flashing. Yeah, heat from the geothermal water is transferred to a second or binary liquid, which flashes it into vapor upon heating, and the vapor is used to drive the turbine. Okay, with dry steam technology, a much rarer fuel source, but the one used in the world largest geothermal power plant at the this one I don't know how to pronounce the in northern California. Okay, geyser or whatever. Okay, highly pressurized geothermal vapor in use of directly. Okay, so it's harness the energy from under the ground. Okay, this one is showing you the uh typical plant size. Yeah. Okay, this one is give you some information about the geothermal energy, and you see that the construction of the geothermal facilities it take 1 to 3 years. Okay, and then operating life is around 30 to 50 years. Then you have to rebuild another one already. And again the word geothermal energy again, this is non-renewable energy. Yeah, depends on the underground water, and then this one is going up, is still going up. Yeah, it is one of the alternative resources. Okay, so total energy, the total annual US in the incident wave energy. Okay, the total energy that they have in the US is 2,100 and 10 terawatt hours. Yeah. So this one is the size of the US wind energy. Okay. This one is show you give you the statistic of the tidal wave energy. Yeah. You can see that the highest is the French side is a 2024 240 megawatts power. Okay. And then China also have 3.9 power, 3.9 megawatt. And this show you the plan for this French one to have what's the wave. Okay, this one is another one to tidal wave plant. Okay, the trend of the energy used in 1990s to year 2000. You can see that the wind energy is annual growth rate is 25%. There are more and more people using the wind energy. Solar cell 20%. Geothermal is very low, 4%. Hydroelectricity 2%. Natural gas 2%. And oil 1%. And nuclear energy that people say that can generate a lot of energy, high amount of energy. The growth rate is only 0.8% per year. Okay. And coal, there are less people using it. Is a negative growth rate. Yeah, people are trying to phase out the coal because it's causing an environmental issue. Okay, so from this figure, you can see that the most potential and alternative energy sources will be wind power and solar cell. Okay, solar cell, if we can increase the efficiency of the conversion rate, then it will be good and also lower down the cost. Yeah. Okay, now let's look at the renewable and new sources of energy. The renewable and new sources of energy is gain. The gains are driven by hydroelectricity and burning of waste and biomass of not new technology. The waste of biomass is no longer a new technology. Yeah. Okay. No major near midterm breakthrough are anticipated. That's mean during this maybe 10 to 20 years time, we are foresee there is no major breakthrough, especially in the wind and solar energy. The scientists need more time to have a breakthrough. Hydroelectricity may prove to have significant risk and negative environmental impact in some Asian countries. So again, this statement is conflict with and the advantages and disadvantages that we have mentioned just now. Okay, and which one is right, which one is wrong? There is no right or wrong answer here, but it depends on which angle are you looking at. Okay, which perspective are you looking at? So issue like clean coal, gas liquefations, and safe nuclear will each be far more important than all issue affecting the new source of energy. So if they foresee that the coal, the clean coal, not the coal, the pre-washed coal and the gas liquefaction and the safe nuclear will have a more important role. Okay, even here I mentioned about nuclear. Total net environmental impact on many new technologies like methanol, battery power car, blah blah blah, may be a negative as burning petroleum. They may be, as compared to burning of petroleum, they may have a negative impact on that. Okay, the US is now virtually the only nation conducting major experiment in significant commercialization of new technologies. And the impact on the US is very limited and produce questionable net energy gain and environmental impact. So the only country that is very serious and is working very hard to find the new energy source is US. Yeah, because their country during the their lifestyle, everything is very much depending on the energy. Yeah, so they need a lot of energy. So that's why they are working very hard to discover a new energy. Developing nations cannot afford regulation and non-economic choice. If you want the developing nation or the third world country to install a very expensive nuclear power plant or wind turbine or this geothermal, they cannot afford the cost. Yeah. Okay, that they lack the research and the development and industry base to conduct major program. Okay, so they do not do any research on that. Fusion is effective a non-starter for the near midterm, and no prediction is possible for long term. This is talking about the nuclear technology. Yeah, currently the technology that we use for nuclear is fission. FISSION. Fusion is another type. Yeah, and geothermal is a non-starter. Biomass show little sign of major technology growth because it is the amount of biomass is also not high. Yeah. Solar electric is the area where significant breakthrough is at least technical possibility. Okay, it's at least a technical possibility. So that means that the solar energy, there is a high chance that it will have a breakthrough in the near terms. Okay, so this is the new source of energy. Next, let's look into the nuclear fission. This one is fusions. The one we are looking at is fissions. Yeah, so there is a nuclear that we are using the uranium 235. Okay, uranium 235 then is hit by a neutron, and then it will generate uranium 236. Then at the same time, it will form a barium and krypton and plus 2 neutron. And this process is exothermic. It will release out a high energy. Okay, critical state when one neutron then collides with the uranium. Supercritical when two neutrons produce collide with the uranium, and ultra critical is when three neutrons collides with the uranium. Yeah, but the problem of this nuclear energy is they are have the material is having a very long half-life. Half-life means if you want to reduce the mass, for example, from 10 gram to 5 gram, you need to take how long? Okay, now let's look at some of the uranium. Yeah, some of the metal. You see, uranium 238. You want to reduce the material from 10 gram to 5 gram, it need to take 4.47 billion years. It's very high, isn't it? Thorium 234, 24.1 days, not so bad. Okay, and then uranium 234, 24,500, 245,000 years. So it take if you want to get rid of the radioactive material, it take millions of years, take thousands of years. So this is a problem with the radioactive waste. Yeah, and you can see that there is no uranium 235 here. Yeah, because the main source of uranium 235 is coming from uranium 238. Yeah, around 0.7% of the uranium 238 consists of uranium 235. Okay, energy conversions. Yeah, typical heat value of various fuel. You can see that the efficiency of the energy produced. Firewood, it can only produce 16 megajoule per kilometer, per kilogram. Okay, and then the black coal 24 to 30, natural gas 39, higher. Crude oil 45 to 46 megajoule per kilometer, per kilogram. Yeah, and uranium in light water reactor, you can see that you can compare this figure 500,000 megajoule per kilogram of uranium can produce 500,000 as compared to crude oil, natural gas. That is how many times more efficient than the other natural resources. Yeah. So next is the non-recoverable resources of uranium. Mainly is Australia. Okay, the country that now have a large reserve of uranium, that is Australia. Okay, the main one is Australia. And it come to US, it is not so much. It's only 102,000%. Its contribute to the world percent is only 4,000. Yeah, whereas Australia is supplying around 30, not 4,000, sorry, 4%. And for Australia, it is around 30% of the world supply. Okay. So when we talk about nuclear energy, there are three things that we usually talk about. There is a moderator, the coolant, and the control rod. Okay, let's look at it briefly. What does it mean by moderator, coolant, and control rod? Moderator is a substance used to moderate or slow down the speed of the neutron. Okay, to increase the chances of collision. It slow down the speed of neutron so that it can collide more with the uranium. Okay, with the radioactive atom. Moderators are used include graphite, heavy waste, heavy water, hydrogen or dioxide, normal or light water. Okay, so this is a moderator. And then coolant is a liquid used to cool the radioactive core and transfer the heat to the heat exchanger or boiler. And coolant use include heavy water, light water, and liquid sodium. The control rod are used to absorb the excessive neutron and so keep the rate of fissions at the required level. And control rod material is including graphite, boron, and etc. Yeah. So now this is just a brief explanations about how does the nuclear power is generated. A neutron will more easily hit a nucleus if it moves at a lower speed. That's why we need a moderator to slow down the speed of neutron. Okay, here too a moderator is used. It acts like a sort of brake on the neutron, and then the moderator can be a substance such as water, graphite, PWR reactor are used the water of their primary circuit and as the moderator. The neutron first hit the water molecules and thus lose a speed, enabling them to hit a fissile nucleus. Okay, using water as a moderator has a great advantage compared to graphite. First of all, it is not flammable, and if the water temperature increase above a certain level, it would simply start to boil. And with the corresponding bubbles inside this bubble, there would be no water, okay, and thus no moderator. Without a moderator, the neutron would not lose speed, okay, it will not slow down its speed. When it do not slow down its speed, then the chances for it to collide with the nucleus, there will be less, okay, and would thus not be able to induce fissions. Yeah, the reaction would eventually stop. So the characteristic is called negative void coefficients. Yeah. And coolant, the purpose of the nuclear fission process is to produce heat, right? What we want is to produce heat energy. And the fission fragments that are produced by the fissions then slow down in the field, losing most of their energy. The energy is converted to heat in the fuel cell, in the field. Okay? A coolant is used to remove the heat and maintain the temperature of the field within acceptable limits. Sometimes the coolant is used to cool the moderator also. Yeah, to cool the moderator, which in turn can be used to cool the fuel. Sometimes the coolant cools the fuel by passing around the rods containing the fuel. Sometimes the moderator and the coolant are used as the same material, that is water. Okay, so this is the coolant. And then the absorption of neutron or the control rod. At each fission of a nucleus, 2 or 3 neutrons are released, but a control chain reactions until only 1 new fissions by a single neutron. Okay, the surplus in neutron must be eliminated, as part of them will be captured by the wall and internal structure of the reactor vessel. The remainder must be absorbed. Okay, by adding a boric acid to the primary circuit water and by inserting a control rod, usually it's indium cadmium silver alloy or boric baric carbide in the reactor vessel, neutron can be absorbed and these reactions can be controlled. Okay, so basically the control rod is to absorb the neutrons. Yeah. And there is another new technology, not new technology, but it's better technology called mixed oxide field. Okay. When, as I mentioned just now, in the chart there, we do not see uranium 235 because uranium 235 is contained in the uranium 238. 99.3% of uranium 238, when we do the mining of uranium, 99.3% is uranium 238. Only 0.7% is uranium 235 that can use for this fission process. Okay, uranium 238 cannot be used for fission process. Uranium 238 partially burned when converted to proton 239 in the nuclear reactor. Okay, and majority of proton 239 form untouched in span 235 uranium 235 fuel rods. Proton 239 can be recovered as plutonium oxide, and mixed with uranium oxide and mixed oxide fuel, and then become a MOX, the mixed oxide fuel, to be used in the nuclear reactor. Okay, and plutonium 239 is also used in nuclear, which is also used in the hydrogen bomb lah. Okay, nuclear warhead formed in a special fast breeder reactor. As in plutonium 239 is very dangerous. You can use it to make nuclear weapons. Yeah. So using the MOX, a higher amount of uranium, that is, we mix up the uranium 238 and 235, can be burned to produce more power from uranium oxide. Okay, because MOX is used uranium 238. Okay, you can use uranium 238 directly. Now, next is the advantages and disadvantages of a nuclear power plant. And then this one again, the advantages and disadvantages may change. It depends on the context. Okay, if the question asking you what are the advantages of using the nuclear power plant in okay, let's say let's say what is the advantages of a nuclear power plant located in let's say in Indonesia and in Malaysia. Okay, currently both countries also don't have a nuclear reactor plant. We just imagine if let's say yes, then the advantages is basically the energy generated are all very high, but Malaysia we are free of earthquake. like Indonesia is there is earthquake prone area. Okay, so the advantages of Malaysia is we do not have a natural disaster that can possibly destroy the nuclear reactor. Okay, but to the Indonesia, this could be a disadvantageous. Okay, so when we talk about advantages and disadvantages, you always always compare with the context given. Okay, whether the context is Malaysia or Indonesia, then you have to see. In Malaysia, it could be advantageous. In Indonesia, it could be disadvantageous, or vice versa, right? So next is the advantages. High power production. As just now you see that the 500,000 megawatt megajoule per kilogram of uranium. Yeah, it generate high productions, high power productions. Use up plutonium from disarmament. Okay, you up the plutonium that get it from the this disarmament of the nuclear weapon. No further production of plutonium waste. There is no further waste being produced. Extend use of uranium metal. Okay, extend use of uranium metal. This is the advantage of MOX. Yeah, not nuclear energy as whole. It's a MOS. Yeah, and disadvantages is problem with recovering plutonium, even though it does not causing any waste, but the recovering of plutonium is a tedious process. Yeah, and possible loss to terrorists or nations. So because the plutonium and all these nuclear metal or material that we can use it to make convert into the nuclear weapons. Okay, so in case it is lost to the terrorists, then you are in trouble. Okay, and especially that during the transportation of the let's say uranium from Australia to the destination power plant. Okay, so during the transportation security need to be very tight. Yeah, in case it is attacked by terrorists or whatever, then it may cause a problem. Okay, now next is the mixing uranium. It's the upstream. This is the mining side. Not mining, not mixing of uranium, mining of uranium. Okay, what happened to mining of uranium? It must be more than 100 ppm in the rocks that only we start mining. That means the rock it contains of 0.01% of uranium 235. Then we mine it and use open cast or underground mining and in-depth in-silt leach process. This is the process of mining. Uranium mine tailings radioactive. Okay, the leftover from the uranium mines, it will causing this radioactive material there. So the groundwater polluted by heavy metals and radioactivity in waste. Okay, so there is a high radioactivity in waste caused by thorium and radium. Half-life of thorium 230 is 75,000 years. Okay, and half-life of radium 226 is 1,600 years. So that is very long. So the mining itself is causing pollutions to the land. So usually after the mining, the tailing just left over there because it's too radioactive. Yeah, and half the workers involved in cleaning waste, in cleaning the waste. Yeah, principal health problem, it cause a problem: lung cancer from inhaling uranium and decay products. Also health problems from contamination of groundwater. So this is a problem that faced by the upstream, the mining of uranium. So when we're talking about the energy supply, let's say for example, we're talking about hydroelectricity. We say that the building of hydroelectricity dam causing the land pollutions, need a big piece of land. And then when talking about nuclear energy, not only the building of nuclear energy power plant need lands, but during the mining process, okay, is also causing quite a number of problems as mentioned here, right? So next, let's look at distributions of your export of Australia uranium. Australia is export most to USA, okay, then followed by Japan and Eastern European Union, yeah, and Canada is very little, okay. So their major customer is still USA, US, and then Japan. Okay, when talking about the nuclear energy, actually during the nuclear energy during the fission process or whatever, it emit out different type of wave. Okay, and there are certain wave that it is you can block it by the skin. For example, if it is an alpha wave radiated, you can easily stop by the skin. It won't penetrate through. Okay, so this gives a less problem. But if it is emitting a beta wave, then you pass through your skin, pass through your body. Your skin cannot stop it, but it's only the aluminium wall can stop it. Okay, and if it's radiated the gamma ray, which is similar to the X-ray, it will penetrate through even the aluminium wall, and then it will only can stop by the lead. Okay, so this is very dangerous. And then the worst one is the neutron. Okay, just now we say that the neutron is captured by the control rod, right? Okay, so it's confined in the reactor side. But if there is a leakage of a neutron, then it can penetrate through even the lead wall. Okay, it can only stop with a very thick concrete wall. Okay, so that's why the spent fuel rod or whatever that is still very radioactive, people are storing conceal it with a thick concrete wall. Yeah, so this is the danger of the different type of wave. And downstream effect. Okay, USA produced 32 tons of high level waste. We will look at it, what is high level waste and what is intermediate level waste later. Yeah, and the European Union 80,000 meter cube radioactive waste, of which only 150 meter cube is high level waste. Okay, so it's very little high level waste. All materials in contact with nuclear fuel radioactive and must be treated as low level waste per keep in situ. Okay, any materials that in contact with the nuclear fuel is considered as radioactive. Okay, and is classified as a low level waste. Yeah, high level waste in various strategy places with both physical and environmental security. High level waste are kept in the various strategy location with a very strong physical and environmental security. Physical security is mainly because you worry that you're going to the hand of terrorists, and the environment is worried about the leakage of the radioactive waste. Okay. Now let's look at what is the problem with the nuclear reactor power generations. The first thing that is it is high cost of nuclear energy versus fossil fuel, because the maintenance of a nuclear power plant, the building of nuclear power plant is very costly, especially the maintenance, because it is very dangerous. In case accident happen, it may cause a big problem. Okay, so in that case, it is very high cost to maintain the nuclear energy or operating cost of the nuclear energy plant as compared to fossil fuel. Okay, and because of that, after certain years, the many plants are shut down instead of building the first plant, or because the maintenance cost is too high, they just shelve it, just stop it halfway. Okay, and another problem that caused by the nuclear power plant is nuclear safety. Okay, the nuclear accident. If let's say there is a nuclear reactor is having accidents, there is a meltdown or whatever, then it will cause the whole place will be very radioactive and nobody can stay there. Example is the 3 Mile Islands, but this one nearly happened, but it's not real. It's not go into an accident yet. But Chernobyl is a very bad this nuclear accident. Okay, and for your information, now the Chernobyl like a ghost town. Nobody are staying there. And when people go there to check the radioactive level, it is still very high. Okay, and because of the Chernobyl disaster, the meltdown of Chernobyl nuclear reactor, the radioactive material was detected in the Europe side also. It go until the Europe side. Okay, so the radiation sickness, the nuclear energy may cause a radiation sickness, and transportation safety, as I mentioned just now. You want to transport the material from Australia to let's say the USA. Okay, so you need to have a very tight transportation security. Otherwise, in case anything happen, hijacked by the terrorists or whatever, it may cause problem. Yeah, it will cause hijacked by terrorists, it will cause nuclear proliferations. Yeah, so this is the nuclear safety. And then another third problem is we are facing problem with the waste disposal of the waste product, the used spent rod. Okay, even those now we are exposing we have a technology, so-called technology, to dispose of the this used fuel rod, but the technology is still not so matured yet. Okay, we still don't know how to get rid of this half-life issue and so forth. Okay, just now we are talking about different type of wave, right? Like for example, the alpha wave can stop by the skin, and then the gamma wave or X-ray can stop by only the lead wall. and then the beta wave can stop by the aluminum wall, and then neutron, you can go through all these except the very thick concrete wall. Okay, so let's look at what are these radiations. Yeah, the type of radiation, nuclear radiation, arises from hundreds of different kind of unstable atom. Because of the unstable atom, so it radiate out the radioactive waste. While many exist in nature, the majority are clear in nuclear reactions, are created in nuclear reactions. Yeah, majority of them are created in nuclear reactions. Ionizing radiation, which can damage living tissue, is emitted as they change or decay spontaneously to become different kind of atoms. Yeah, the principal kind of ionization of radiation, the main wave that is alpha, beta, gamma, and this neutron. Yeah, alpha wave is a particle that are intensely ionized but cannot penetrate the skin. Okay, so are dangerous only if emitted inside the body. So it is only because it can stop by your skin, so it won't go inside your body. Okay, it is only dangerous if, let's say, the alpha particle or alpha radioactive wave is emitted inside your body. Okay, then radon gas given out by many volcanic rocks and uranium are all has decay products that are emit alpha wave. Okay, this is why radon can be dangerous. People everywhere are typically exposed to up to 3 MSV per year from the inhaled radon without apparent illness. Okay. However, in an industry situation, it is controlled as a high priority. If we are naturally exposed to the alpha wave, okay, 3 milli SV per year. This is the measuring unit. So they do not show any ill effect on that. Okay. Industry use, it is but in the industry, the people are treated as a dangerous material, then they have a high control. Yeah, the control is priority. The next is the beta wave. Beta particles are fast moving electrons emitted by many radioactive elements. They are more penetrating than alpha, but easily shielded. Okay, they can penetrate through your body, penetrate through your skin, but it's shielded by aluminum. Okay, and gamma, the high energy beams, which is almost same as X-ray. They are very penetrating and require shielding. Okay, radiation, those batches are worn by worker in exposed situation to detect them and their monitor their exposure. Okay, those workers are working there are required to wear the badge, and the badge will change color or whatever to indicate that the exposure limit. Okay, and have you seen people wearing the radioactive badge, radiation dose badges? For example, like if you go to a hospital, when you do for this go for X-ray, right, the one who help you to do the X-ray, they are wearing a badge on their put a badge on their clothing or in their uniform. Okay, this to show their exposure limit. Yeah, and all of us receive 0.5 to 1 milli SV per year of gamma radiations, but from a cosmic ray and from the rocks and some other places. Okay, so it is naturally we are also exposed to all this gamma ray. Okay, and the most dangerous one is a neutron that can penetrate through even the lead shield. Okay, neutron are mostly released by nuclear fissions, and this one is only happening at the nuclear reactor, the splitting of atom in the nuclear reactor. Okay, and hence there are normally not normally a problem outside nuclear plant, because it only confined into the nuclear reactor. So outside the nuclear plant, usually there is no neutron being emitted. However, fast neutron can be very destructive to human tissue. Yeah, just in case you are exposed to neutron, it's very damaging. Yeah. Okay, so this is the wave that you're talking about from the nuclear energy: alpha, beta, gamma, and neutron. 4 different type of wave. Okay, even though the most dangerous wave is this neutron, but it's only happened in the nuclear reactor during the fission process. So there is a minimum chances for it to leak out from the nuclear reactor. If the safety precautions or the maintenance is not high, or any accident happen to the nuclear reactor, then it may cause a problem. Okay, the neutron may be a problem. Okay, like just now we're also talking about high level waves and low level waves, right? Let's look at the classification of the radio wave. Okay, the high level wave is resulting from the reprocessing of spent fuel, from the reactor, yeah, the amount of plutonium and other heavy isotope remaining in the solutions is similar to the original plutonium and uranium. Okay, and the residue consists of mainly fission product. So this is high level waste directly from the nuclear reactor. And then spent nuclear fuel, the used nuclear fuel, this is discharged from the reactor. This is coming out from the reactor and may be stored at the reactor site and eventually placed in a waste repository without reprocessing. Okay, in which case it is treated as a high level waste until it is reprocessed at a later stage. You might keep this spent nuclear fuel near the nuclear power plant, but if we keep it there, we are considering it as a high level waste, yeah, until it is reprocessed at a later date. Transuranic waste, TRU, this is a waste material that is contaminated with alpha emitting radionuclide with a life of over 20 years, yeah, with a life of over 20 years, and of element with an atomic number of 92 or more, and concentration greater than 100 nanonuclear per gram. The group includes all transuranic nucleus except plutonium 238 and plutonium 241, okay, and includes a uranium 233 and its all daughter products. So this is the transuranic waste, TRU, and then the intermediate waste level, intermediate level waste. This is the with a high enough energy radioactivity. Okay, still have a very high radioactivity, is to create the need of a special treatment and disposal. Yeah, we need to have a special treatment and disposal. This group include cladding separated from spent nuclear fuel, filter, and other waste from the effluent treatment, worn out plant and equipment, isotope used in the medical treatment, radioactive material used in industrial and defense. A company called Nirex, owned by the nuclear industry, has been set up to dispose of this waste and has planned to use underground repository. So how are we going to dispose it? Usually we are buried it underground, okay? And then it's just a matter of time, whether it causing a big problem to our Mother Earth or not. Okay, we cannot get rid, we cannot convert it into zero waste. Yeah, that the problem is. If we store it in the underground or whatever, and due to the half-life, then it take thousand years or million years to decompose, becomes zero. Okay, low-level waste is the waste has very little radioactive contaminations and contain no TRU elements. Little or no shielding is needed. Okay, so this is a low-level waste. Mainly is a gamma ray, alpha ray, that is a very little of radioactive contaminations and no shielding is needed. Hence, it may be buried near the surface. Okay, so it includes rubbers and the steel work from the decommissioning of reactors. Right, most of this waste is currently disposed of at the Drake site in Cumbria, operated by the British Nuclear Fuel. Okay, so they have a designated place to store the waste. Okay, mill tailings, the leftover from the mill tailings from uranium mills are another sort of waste which lower level of radioactivity. They contain elements such as thorium and radium. Just how we have seen that thorium and radium also having a very long shelf life, half-life, isn't it? Right? And it's very, very radioactive byproducts of the decay of uranium 238, not removed when extracting the uranium. The tailing leave the mill as a sludge and are allowed to dry. Okay, there is obvious hazard here of a contamination of the local water supply by the surface runoff from rain and by wind blow dust into the atmosphere. As I mentioned just now, the Chernobyl incident, the Europe side also received the radioactive particle. That is because it's blown by the wind. Okay. Now, since we have generated so much waste, so how are we going to treat the waste of the nuclear energy? One of the way is the disposal of low-level waste, originally disposed by dumping sealed steel drum into sea. Later, okay. So we put all the low-level waste into a sealed steel drum, okay. And where we go, we dump it into the oceans, dump it into the sea, okay. And so next time when you have a submarine inside there, you may be able to see, oh, there is so many steel drum there. They are all nuclear waste, okay. Due to the public outcry, economy grounds now treated as ILW, okay, intermediate Now this one is treated as intermediate lower waste, yeah, intermediate level waste, ILW, yeah, intermediate lower waste. Originally, it's treated as a low level waste, but because of the people are worried about the radioactive side or whatever, so now it's treated as an intermediate level waste, yeah. And disposal of intermediate level waste, how do we dispose it? We entomb it in a solid matrix, okay? We use bitumen, cement, or plastic, and then bury it under the ground 100 meters under the ground. Okay, can you imagine? We instead of we have this not no longer a steel drum, but it could be a bitumen or cement drum with a thick wall, and then we need to dig the ground under 100-meter depth, and then only we buried it. Okay, so this is how we dispose of the our intermediate level waste. And when we're talking about the land pollution or land resources, we are saying that there is scarcity of land, isn't it? Right? The carbon footprint for land is 1.92 hectare per person, and due to our lifestyle, we need 3 to 4 times higher than what the Mother Earth can supply to us. Right? So we already have shortage of land for agriculture, for human rehabilitation, and so forth. But now we still need a land to bury this intermediate level waste. Okay, so our land will become lesser and lesser if we have more underground waste. Okay, this one is only the 100-meter is only the intermediate, right? How about the high level waste? The high level waste, especially consideration because high level waste is heat producing. Okay, the high level waste is heat producing, so we need to store it store it in a concentrated nitric acid in high integrity double wall stainless steel container in concrete walls with coolant coil. Okay, so you see that itself is generating heat, so we need to store it in a concentrated nitric acid in a high double wall stainless steel. Okay, and also containers in a concrete vault with cooling coils. When the waste were verified into glass-like A stage, stored in ponds or naturally ventilated air store. This is the second step. After 50 years, okay, 50 years later, you already retired by that time. When no more heat emitted, bury the waste deep underground for 500 meters. Okay, the intermediate waste is 100 meters underground, and then this high level waste is 500 meters underground. Okay, and it is not immediately you can bury it. You need to wait for 50 years. After 50 years, then only we can bury it. Okay, so then the disposal of the waste from the nuclear power plant is actually is a problem. Yeah. Okay, this picture show you the inside the power nuclear plant. Okay. Okay, next, what happened if after the nuclear power plant is old already, we want to stop the operations of nuclear power plant? What are we going to do? Okay, so the mothball spent fuel rod is processed in the UK. It processed in the UK and take 5 years due to the handling of capacity. You have to dismantle the fuel rod or coolant. It need 5 years. And entombment, removal of everything outside the biological shield, seal and weatherproof main structure, and removal of everything else. And then all this will take years, okay? And then the abandoned site that nobody can stay inside there. Okay, just now we say that nuclear safety is one of the problem, right? But in the recently there are some improvement on the safety of nuclear energy, okay? And because of the increase on the safety side, so there are people things to construct a power nuclear energy plant. Okay, I'm not sure whether you are aware or not. Malaysia is also 10 years more than 10 years back. Malaysia also have an intention to build a nuclear energy power plant. Do you are aware about that? Now Malaysia we have how many nuclear reactor? Anyone knows?
Don't
We
know.
have, huh? Sorry.
Don't know.
We have only one. That is in the Malaysia Nuclear Agency. Okay, we have only one. There is a small one for experimenting purposes. for carry out experiment and testing purpose. Okay. Previously, our government did announce that they want to build, because of we gear towards the industrializations, our current supply of electricity may not be sufficient to support the industrializations. So they are planning to build a nuclear energy power plant, okay? And it is targeted to start operating in 2021, okay? That is this year. But after change of government and due to some other issue, this plan was put aside, okay? It's not materialized, yeah? So improving nuclear safety, what are the things? Use of reinforced concretes instead of welded steel containment vessel. Okay, this one for the waste, use a reinforced concrete. Development of small low LWR using passive safety system that is gravity feed, natural circulations, duplication of safety and monitoring system. So we have the double. Okay, if one is out of order, then another one is still functioning. So we got time to do the what you say the repairing job. Sharing of knowledge experience, okay, resulting in a better understanding and contingency plan for nuclear accident. Promotion of operational safety and reliability of nuclear plant. So these are the improving safety side. So if the question asking you why nuclear is becoming popular now, then one of the reason definitely is it's very high power, energy to weight ratio. You use 1 kilogram of uranium-238, you can create 500,000 megajoule, as it is much higher as compared to other energy resources. Then definitely they improve in the nuclear safety. All these 5 points here can be your answer. Okay. Nuclear issue. What is the issue with the nuclear? Gains are offset by losses. Okay, the gain are offset by losses. U.S. demand projected to drop an annual average of negative 1.8%. It's dropping. They are trying to go away from the nuclear energy. Western Europe peaked at 2000, but output then dropped steadily as older reactor are phased out without the replacement. Yeah, the Western Europe they are not replacing their old reactor. Japanese increased the output by 1% per year. China increased 11.6% per year, and then India is 6.7% per year, and rest of Asia is around 3.2% per year. Okay, and Middle East there is no show a real growth. Okay, Middle East they are not worried because they have plenty of oil there, right? So demand would be far higher if safety and permitting respond to the market force. So if let's say the safety issue we can overcome it, then it is much more when the more people will be using it. Okay. Nuclear power, are we ready? What do you think? Is Malaysia ready for nuclear power plant?
Oh, no.
There is a mix. I asked this to other groups. Yeah, one of your tutorial that we are going to try out is these questions. There are mixed opinion. There are some say yes, some say no. So it depends on which angle, which perspective are you looking for, right? And there is a news saying that the TNB aim to start a nuclear plant by 2025. Another 4 years, we are going to start the building of a nuclear power plant. Okay, so whether it will be put aside like as the previous plan or not, which we do not know, right? So that's all for the nuclear energy. Next, we go to the hydrogen economy. That's means we are using the hydrogen to generate energy. I think you already know that what type of energy is that, isn't it? A sustainable hydrogen energy industry, an energy system based upon the extensive use of hydrogen as an energy storage and transportation medium. Okay, why we want to use hydrogen? Because it establishes an environmentally and economically sustainable world to be left for our children and grandchildren. There is a sustainable development. Okay, it does not harm the environment, and economically it is sustainable. Okay, where can hydrogen be used as a fuel source? It can be used in transportation. You can replace a natural gas. It can use in fuel cell. I think especially mechanical student, you all know what is fuel cell, right? Okay, the one that use hydrogen and oxygen to produce this energy, and become the only waste is H2O, right? Okay, So what is the hydrogen economy? It's a sustainable hydrogen energy industry based upon the extensive use of hydrogen as an energy storage and transportation as transportation medium. Okay, we are using hydrogen to generate energy. Why have a hydrogen economy is to ensure that we leave behind an environment and economic sustainable world for our next generations. Yeah, how does the hydrogen economy does? Hydrogen is abundant in our atmosphere, or there is a lot of hydrogen gas, isn't it? Or we can easily make the hydrogen gas from chemical reactions. Okay, and it is not non-polluting sources of energy. It does not produce any pollutant. So where will the hydrogen be used? Transportation, as I mentioned just now, completely non-steady sources of energy. It complement the non-steady source of energy. There are some energy sources that is not steady, like wind or this tidal wave energy. If it is not steady, or solar energy, then it can be complemented by the hydrogen energy. Okay, replace natural gas, as mentioned just now, to store and transport power from remote production site to point of usage. So advantages of hydrogen over fossil fuel. Remember fossil fuel we have three: coal, oil, and natural gas. Okay, so no local pollutions, air pollution. Okay, there is no volatile organic compound (VOC), no carbon monoxide, acid of nitrogen, and so forth. And if we can use the hydrogen fuel cell to power our car, then we reduce the oil consumption, we reduce the petrol consumption, and it does not causing any greenhouse emissions. Okay, during the use. During the use for the fuel cell, the only waste generated is H2O, water only. Okay, electricity also has this same three attribute, but hydrogen has advantages when required to be stored and transport to remote locations. Yeah, we can store and transport it to a remote location. Syngas is the synthetic gas that where we are producing it. Okay, so the process reaction, for example, is a methane plus water. It will become 3 hydrogen plus carbon monoxide. Okay, so this is if we take the methane plus oxygen to combustion, then we will get water and carbon dioxide. All these are exothermic. There are some is endothermic process. Okay, so this is the way how we can produce the hydrogen. Yeah. But definitely, there are when we produce the hydrogen, there are some pollutant being produced as a side effect also lah. The carbon monoxide, carbon dioxide, all these are side effect. Okay, if we decompose of the methane itself, and then we don't have a pollutant. There is a get the H2O and carbon. Okay, or we decompose the carbon monoxide, then we get carbon and carbon dioxide. Carbon dioxide is a pollutant. Yeah. Okay, the anode, we are talking about the fuel cell. Actually, it is a reverse of electrolysis. Okay, you have studied in your Form 5 science and or your chemistry paper. You see that when you put 2 carbon rod into the water and connect it to a battery, you are using the electricity to do the electrolysis. Then one side you will collect the hydrogen gas, and then another electrode will collect the oxygen gas, right? So this is the original idea, but there is one smart guy. They think that if we can use electricity to generate hydrogen and oxygen from water, how about we reverse the process? Can we use hydrogen and oxygen to generate electricity, and by producing water? Okay, so this is the whole thing about the hydrogen fuel cell. Okay, the anode, the negative pole of the fuel cell, has several jobs. Is conduct the electrons that are free from the hydrogen molecules, so that they can be used in the external circuit. It has channel AH into that and disperse the hydrogen and equally over the surface of the catalyst. And the cathode is a positive. Cathode is a positive pole, as channel etched into the distribution of oxygen to the surface of the catalyst. It also conduct the electrons back from the external circuit to the catalyst, yeah, where they can recombine with hydrogen ions and oxygen to form water. So this is a waste product. This is the byproduct of fuel cell. Okay, the electrolyte is a proton exchange membrane. Yeah, the electrolyte is a proton exchange membrane. This specially treated material which looks something like an ordinary kitchen plastic wrap. Okay, so this is the electrolyte, and the catalyst is the special material that facilitate the reactions of oxygen and hydrogen. They make the reaction faster. It is usually made of platinum powder and very thinly coated on the paper or clothing. So these are the components that in the fuel cell. So what are the advantages of using hydrogen fuel cell? One of the advantages is no pollutions, okay? No consumption of other resources. So that we know it is renewable. There is no consumption of finite resources, and it does not causing any pollutions. And it is high efficiency, and the operation is very quiet and long life and minimum maintenance. The maintenance, why it is very minimum, and modularity. You can change the parts easily. So storage and transportation of hydrogen. We can inject the hydrogen into existing natural gas line and later replace the natural gas. We can use the existing gas piping or whatever to inject in with the hydrogen. Okay, and then we can store the hydrogen, store and transportation of hydrogen in containers. Okay, we can store it in the metal tank, compressed hydrogen tank, and so forth. Or we can have a liquid hydrogen, chemically store hydrogen and in the form of carbon nanotube tube and so forth. So hydrogen energy storage density. Okay, if let's say we are using the compressed hydrogen, we can share to 20,000. Okay, and then if let's say the volume wise is 1,000, yeah. Okay, and then if we are in the gas form is 12,000 for the mass, volume is 9,000. Okay, then what are the type of fuel cells that we have? We have an alkaline fuel cell, phosphoric acid fuel cell, solid oxide fuel cell, and also molten carbonate fuel cell. Okay, what are they? The alkaline fuel cell is one of the oldest design, the most common one, the oldest design. It has been used in the US space program since 1960. And the alkaline fuel cell is very susceptible to contamination. So it requires pure hydrogen and oxygen. Okay, the big point of it is easily contaminated. So the hydrogen and oxygen that you use need to be very pure, and it's also very expensive. And this type of fuel cell is unlikely to be commercialized. Okay, and phosphoric acid fuel cell. The phosphoric acid fuel cell has potential and use in the small stationary power generation system. It operates at a high temperature, and the PEM fuel cell, the phosphoric acid fuel cell, so it has a longer warm up time. This makes it unusable and unsuitable for use in car. Okay, because it generates out the heat. And then the solid oxide fuel cell these fuel cells are the best suited for large scale large scale stationary power generator plant. Yeah, okay, that could provide electricity for factories and town. This type of fuel cell operate at very high temperature, around 1,000 centigrade. This high temperature makes the reliability of a problem, yeah, but it has an advantage. The steam produced by the fuel cell can be channeled into the turbine to generate more electricity, and this improves the overall efficiency of the system, yeah. So the heat generated, we can use it to convert water into steam and to turn the turbine, right? And then there is another one, the MCFC, the molten carbonate fuel cell. These fuel cells are also be best suitable for large stationary power generation. They operate at 600 centigrade. It's much lower than the SOFC. So they also generate steam and can be used to generate more power. They also generate steam, and then steam is used to generate power. They have a low operating temperature than SOFC, which means they don't need such exotic material to in the design of the lens. Okay. So okay, that's all. Up to here. Any question? We have completed the what we say the discussions on the environment, resources, and energy. Okay, so we left last topic is engineering safety. I'm going to discuss with you the energy engineering safety. When we have a class again? Next Tuesday, right? Next Saturday. This Saturday we have class, right? Is it this Saturday? No, this Saturday is diploma. I confused because there are two similar paper. Let me check. Your class next Tuesday we have class. Oh yeah. No, Saturday 17. Okay, this Saturday we have class, 9 to 9 to 11 a.m. So we will finish off with the engineering safety. Then the last week, the Win 14, I will use it for revisions. Okay, and then I will show you how are you going to tackle the question, and how are you going to make use of the lecture notes to answer different type of question. Okay, well basically if you understand the principle, you understand the theory behind there, and then no matter how the question twist and turn, you still know how to answer it. Okay, right. Up to here, I don't want to go to engineering safety. I'll leave it to the next week, this Saturday. Any question?
Sir, can we have the lecture note?
Yes, this one I will upload it.
Okay, thank you, sir.
I will upload it later. So far, you all have only the environmental lecture notes. You all don't have, right?
Yeah, only this one.
Okay, I'll upload it later. Yeah, just within half an hour time. All right. So for your information, the exam is focused on the technology and society, and also the environment issue, natural resources and pollutions. Yeah. Okay, there is the CLO2 and CLO3. Okay, CLO1 and CLO4 has been covered in your assignment. Okay, so the last week, week 14, we have overall revisions, and then we discuss about some of the questions. How are you going to answer the questions? Okay, and how many points you need to write and so forth. Okay, any other question? Okay, if no question, then I will stop the class here. I will end the class here and meet you on Saturday. Okay,
Thank you, sir.
thank you, class.
See you on Saturday.
See you on Saturday. But tutorial, those who are tutorial class one is still on.
Thank you, Dr. Xiu.